listeners, and welcome to another episode of the Get Smarter podcast. Today, we're starting a new series. We're calling this series Ask the Expert. Our expert today is Randy Heisler. He's a vice president here at Lifecycle Engineering of metals, oil and gas, and the chemicals verticals. Prior to joining LCE, Randy Heisler spent over 25 years in maintenance and reliability roles in the steel industry. He's very connected and on some leadership boards for some governing bodies actually in the steel industry. So he helps to make policies there and grow that area of the U.S. Industry. Randy, for LTE, Randy focuses on improving reliability, reducing costs, and increasing capacity in metals, power gen, and chemicals. Welcome, Randy. Thanks for joining us.
Thanks for having me.
So, like I said, we're starting a series called Ask the Expert. This episode is going to include questions that we're frequently asked by customers or people who email us looking for advice, but also some questions that have been submitted to the podcast. So thank you, listeners, for submitting some questions to us. And this episode is going to specifically focus on different maintenance strategies: preventive, predictive, corrective, and we're even going to talk about new emerging technologies, Industry 4.0, and some advanced technologies that you may already be considering as part of your overall strategy. So I'd like to start with a very foundational question for Randy. What is the purpose of predictive maintenance, and how does it compare to preventive maintenance?
Okay, well, you started with the toughest one.
The toughest one. I mean, come on, you're going to come here on the podcast. You think I'm going to start with the easy one? No, you can't go up. You got to come down. No.
I'm just pulling your leg, Tara. Yeah, the purpose of predictive maintenance is to monitor the condition of the asset. Okay, and many times there's multiple technologies used for that. But what you're really trying to do is to detect the failure, or that a failure is starting to occur, as early as possible. So it's really about oftentimes continuous monitoring that's used, and depending on the technology that you might be using one technology, you may be using multiple technologies. Mm-hmm. It's really about trying to detect that something is going wrong, okay, as early as possible. And later on we'll talk about why that's important and what the benefits of that are.
Right. And as compared to preventive maintenance,
yeah.
which is normally done on a set interval, right? So preventive maintenance is normally, we hope it's part of your maintenance that's already planned. You have like a regular interval that you have to do that on,
correct,
right?
Correct. It's really about condition-based versus time-based.
Condition-based versus time-based. So now that we've set that stage, I know that in some of our trainings, in some of our courses, and in our publications, and in fact, even SMRP has a benchmark for this. It's a benchmark that's called the 6-to-1, or some people say the 5-to-1 rule. And this is introducing a new term we haven't introduced yet in the podcast, this term corrective. So what does it mean to have the 6-to-1 or 5-to-1 ratio when people say preventive to corrective? What does that mean?
Well, what they're really talking about is very based in preventive tasks that you may be doing out in the facility, out in the plant, and it's kind of it's one of those little rules, those guidelines that say that if I've done a particular PM task 6 times, mm-hmm. and I haven't found any issue, I may be doing it too often. So if you keep track of that, and that what it allows you to do, or what you should do with that, is look at the frequency of the PM, and you may be able to lengthen that or widen that out. If you're doing something once a month and you haven't found anything in 6 months, maybe we need to do it every couple of months, or maybe we need to change it to do it quarterly. That's really what it's about.
Okay.
it in a sense forces us to think about, the effectiveness of that PM.
Absolutely. I mean,
Why
that's
do
time.
something, right? Why do something if it's not bringing value?
Absolutely. It's time and money that could be spent on a task that is effective. I mean, is there could something bad happen if you're maintaining an equipment too much?
Well, yeah, any time that, it was kind of an old joke that, maybe some of my operator friends would say, oh no, maintenance has worked on my equipment. I'm going to have trouble. Okay. And that's just, it's not just them, kind of making fun of maintenance sometimes. It actually can be a reality, right? Any time that we're in there doing some type of maintenance, it's very easy to, well, in a sense, induce failure. Okay.
Hmm.
Because maybe the PM task wasn't well defined. Maybe we hadn't done it before. Maybe we forgot something, and so on. That in a sense,
Or
causes.
introduce some dust, I mean, or something like that. Introduce some contamination on
Exactly.
what, not intentionally. I didn't even talk about, well, when I was talking about time and cost, I wasn't even talking about the impact to production, that over maintaining, could potentially introduce. But I think what you're talking about is PM optimization as well, right? So,
Well, it really is.
preventive,
That's
yeah.
that's the fancy term. Okay. Is
I'm fancy.
optimizing our PM so that they're most effective and that they're not inducing failure.
There you go. So take that as a back pocket learning, for this episode. That PM optimization. I know we have a lot of resources on our website about PM optimization and the different factors that can be considered. If you see, like you said, this interval could be too frequent, that's not being effective, and it's not stopping the impending failure, or it's not helping. Take a look at that and consider some resources to be put to that if you have them available to optimizing those plans. So I want to talk a little bit about predictive maintenance. This was a question submitted. Why is predictive maintenance becoming a preferred strategy in many industries? Can you provide an example from your experience, Randy, where predictive maintenance was implemented, and discuss the benefits, the outcomes, but also what challenges were faced?
Sure. I mean, I think, moving into predictive maintenance is somewhat of a natural progression.
Hmm.
That, just about anybody you talk to, if you talk about preventive maintenance, they're going to say, oh yeah, we do that. We have tons of PMs. Okay. Even though PMs are great, there's some optimization of sorts that we should consider. And that's where the PDM thing came in. I've been around quite a while, and there was certainly a time where, the PDM technologies were new. But as more and more people, get to the point in their maintenance strategy, that they're ready to start bringing predictive technologies in, and they've got, and there's a lot of pieces to that. It's like, well, do we have people that are trained on those
Right.
technologies? Do we use a third party? But it's becoming more and more prevalent. There's very few folks out there today that aren't doing some type of predictive maintenance, but there are some new technologies happening all the time that
Hmm.
is enhancing what's going on there. But there was a time where people weren't bought in, okay, that predictive maintenance was real and
It would
that
work.
or that it would work. And I got a couple examples. I had in my consulting days, I believe it or not, and this wasn't that long ago, but I had a general manager at a plant say, "Oh, we tried that. We tried predictive maintenance. It didn't work." And well, I was like, "Wow, that's an interesting comment, right?" So I dug in to what happened, what that caused him to think that. And what I found out is that they had a large fan that had failed, but at the same time they had been doing some vibration analysis and things like that on that fan.
Hmm.
And what really occurred is that the folks that were doing the analysis had notified the maintenance folks that that there was something going to go bad, right? Something bad was going to happen. And I won't go into, it wasn't necessarily like it was totally ignored, but it was also, well, we didn't shut down, or we didn't plan it well, or we didn't do it before it failed. So there it failed. So the thought was, oh, well, we were doing predictive maintenance and it failed anyway. Horrible, to think that, that would just destroy the program, but it did.
Right. Well,
So,
but then you have to look at the supporting maintenance practices and just how the maintenance work was being initiated, planned, scheduled, executed. You got to go back to that, right? In that
well,
case.
for sure. And it was also, it goes back to, the relationship between operations and maintenance. And let's
Yeah.
just say, let's call it the ownership of reliability by the operations group. Okay.
Hmm.
I could go on and on with some analogies, but who's in charge of your automobile, you or the mechanic you take it to? That's not always the thinking, in our plants. It's like, oh, well, I operate and you fix. So it's sometimes a cultural issue that can cause, these types of things to happen. So that was very unfortunate. But now let me move to the more positive side for a second. In an example, many years ago, I was in charge of an electrical group that took care of large 360-ton molten steel cranes. And we had a particular crane that did not have a backup, unfortunately, and was having tons of failures and causing the operation to either stop because of it, or hinder the operation. And it was just a lot of things that were going wrong. And so it was critical to the operation. So, we that's where we started to move. We were moving into predictive technologies.
Hmm.
And what we realized is that the problems that we were having had to do with loose connections in the control cabinets of the crane. These are large cranes. There's a lot of vibration in those places.
Hmm.
And connections, wires were coming loose. So, we sent a crew up there on our downturn, the next downturn, with a thermographic camera, and used that, okay, to see where the loose connections were. And then they were able to tighten those up. And it sounds so simple, but just by using that technology, the reliability of that crane went way up. Okay. And we weren't having those issues in the middle of the night. So that's just an example of how using thermography just really stepped us up into the next realm. Because if you were simply doing a PM, you'd go and look in that cabinet, and you wouldn't see that.
Visually, yeah.
Yeah, right. You wouldn't see that the wiring is loose unless you went around and tightened up every screw. So just an example of how predictive maintenance was implemented, and what a difference it made.
Well, thanks for those two stories. I think those were great, and I just want to tease out a couple of things I heard. One is you're talking about this being many years ago, and I know I've got some friends who have been, in the industry for a long time, that talk about using a screwdriver for vibration analysis by putting their ear down on one end of a screwdriver and like listening to the machine. I mean, we're decades and decades, from when Predictive first came on the market. So I gotta think that it's more accessible to people now, which is also why maybe money as well is more accessible to people, which is why people can consider it more now. But another
Yeah,
thing
the
I
only the
heard,
only question people have today, Tara, is how to accomplish it, whether they invest in the internal resources or
yes.
external.
And another thing, so we'll dig into that in just a minute. Another thing I heard you say was it was a very critical piece of equipment for us. And I think that is another good takeaway for our listeners is, let's say that uh, you are already, or you want to put a business case in to start with some predictive or even more advanced technologies. Is that the place to look? Like, put it on, make sure that you're focusing on certain pieces of equipment or certain failures, or, what are some ways that people could, I guess, get started with technologies, and which technologies should they consider?
Well, let me start with the criticality piece. We always try to point people towards identifying, what are their most critical assets. It really should be the one of the basis, of a maintenance strategy, so that you can focus on the most critical assets, and get the right maintenance strategy in place, build the right PMs, put the right PDM technologies in place, and it's also a way to sell it, right? If people aren't big believers, one way is to start, on one piece of equipment and doing some predictive maintenance, maybe doing some vibration analysis on that to show, what the benefits are and capture the benefits, and even looking at if that asset had failed,
Hmm.
what effect would that have had on the operation? And if those repairs, if it shut the operation down and those repairs had to be done right then and there, that comes at a greater cost than what it would be in a planned environment. Anyway, not to get too far off topic there, but the criticality is huge. Depending on your budgets, you may not be able to apply these technologies across the board on every asset. So it's very important to understand, what are my most critical assets? Maybe I can do 10% of those and start a program. It's all about, to me, risk to the operation.
Yes. Risk to the
Was there another part of
operation.
that question that maybe I missed, Tara?
Well, what are some predictive technologies that
Uh,
people should consider?
there's several out there. The number one that people typically move towards is vibration, right?
Right.
So you're doing vibration analysis, and you may be having a PDM tech that's going out there on a regular basis and checking for the vibration levels and doing some analysis on that. Another one is thermography, like I mentioned, ultrasound, lubrication analysis. It can go on and on. There's you name it. There's ways to look at the speed of the asset with accelerometers. There's a whole lot of technologies out there today, and I think maybe there's a question later that came in that has to do with trying to put sensors in place
Yes.
that can not only look at vibration, but can look at multiple aspects within one sensor. So there's just
Yeah, and overall
tremendous
asset
amounts of.
health. I think that's a good. I think that's a good segue into talking about moving from predictive, we'll call it, I guess, predictive and beyond. But just before we do, another thing you mentioned was, in-house or outsourcing. There are lots of vendors out there, and there are vendors that will probably help you make a business case too. But I think it's probably, well, and you tell me what you think. Um, it's probably on the folks in the plant to determine what's really eating their lunch. What are their critical assets, and where are their most critical failures, and what technology might be best suited to it, and do the homework there, and then find some people to talk to where that's their business.
Right,
That's
and it's always and should be a collaboration. The thing you want to be careful of if you are using a third party is that they're going to want to do analysis and do these technologies on every asset, right? Because that's where they make their money.
of
So
course.
kind of goes back to making sure that you collaborate on what are the most critical assets, and then what is and we haven't talked a lot about this, but is understanding the failure modes.
Failure modes.
And then
Failure
those
modes, effects
failure
analysis, reliability centered maintenance.
right. Yeah, those failure modes will dictate what technology is needed.
I think that's excellent. I think that's an excellent takeaway for our listeners, and that's a lot of the work that life cycle engineering and our reliability engineers do to help our customers, because it's really time consuming to do that analysis. But yeah, let's move on. I want to move on to predictive and beyond.
Mhm.
Let's talk about IoT. Let's talk about what role is that playing now, and like evolving to be in predictive maintenance as we know it.
Wow, this is where it gets pretty exciting.
Yeah.
There's tons of buzzwords out there, the IoT being one of them. The industrial Internet of Things, but Industry 4.0 is
Industry
another
4.0.
buzzword that's out there, and so it's we're now there's a lot of people wanting to understand it. Okay, they maybe gotten familiar with somebody going out there and doing some vibration testing and looking at the thermography, the heat that's being generated, and they're comfortable with that. And in some cases, some have moved into online monitoring that is wired, right? So,
Right.
and you can't do that everywhere, maybe based on conditions that are out there. So that has now moved folks into online wireless sensors, okay? That have, once again, another step up into cloud-based analytics, okay? Where you've got some of these sensors today that are not only wireless or maybe using Wi-Fi, but are also or can be cellular,
Cellular
right?
for more remote locations.
Exactly. The many times, and I'm an old steel guy, that these big metal buildings that your plant is in, sometimes you don't have a good Wi-Fi signal. So the cellular technology is really, really, gaining some ground. On top of the fact that, these are wireless, right? And you don't have
Yes.
wiring, you don't have conduits, you don't have to have panels, you don't have to have anything. And some of these are so simple, you can just, there's many ways to attach them, but you can just glue them on there. You can use magnetic little bases. These things can take just a few minutes to install. So it's just off the chart out there right now, what's available. The biggest challenge is people trying to understand artificial intelligence, right? And understand machine learning. And that's where we're now moving into is these wireless sensors that can be cellular. The information coming from them goes into a software program that lives in the cloud, so you don't have to have servers on site. And then they've got folks will have experts that can sit miles away, right?
Right.
That can see what's happening out there with your equipment, right? Or you can
Right.
have internal folks that are doing that. But that's where we're at today. And you'll hear the term predictive analytics.
Analytics. Mm-hmm.
And those us real nerds out there that are into this type of thing or just get real excited about that, because it's we're moving into a realm that you're now getting enough data and enough analysis through artificial intelligence and machine learning that's built in to these software programs, that you can start to actually predict when, not that it's going to happen, but when it's going to happen. When is that failure? Okay, there's a high probability that this thing, and I'm going to get real specific here, and probably too specific, is that this thing's going to fail next Thursday. Okay, that's where we're headed, and it's just pretty exciting stuff for reliability engineers out there.
Sure. Hey, no, I just heard some planners and schedulers. Like, I just heard, a lot of cheering, right? Because they know when they got to
Oh,
get it on the schedule. But
well,
back to that
that's
story you were talking about, the steel guy. They got the notification, right, that something was going to happen.
exactly, and now you're just getting better and better, ability to plan and schedule, the corrective work that needs to be done, on a particular when if you're taking some downtime or an outage, that you can plan, okay, and get this thing, back in shape before it fails. So it's huge, and the benefits are, just off the chart if you compare what it would have cost if it had stopped the operation as compared to what it cost under a planned environment. And those are completely different numbers that, I tell folks that, it can be very worthwhile to understand based on your operation. But let's just give an example that if when your operation is shut down, it's costing you thousands of dollars a minute.
Hmm.
Do the math.
Right.
And that type of putting these type of technologies in place so that you don't have that happen. These things can pay for themselves.
The programs can pay for themselves and the investments. can pay for themselves. But it does require a certain amount of discipline within the organization, right? To act on and to um, not only recognize, that the impending work needs to be done, but to have the discipline in the organization to get the work done, right? And to have the discipline in the organization to record that that work was done
Oh yeah,
and
if
learn
you
from that, because right.
oh yeah, well you can start with if you ignore what it's telling you, it's all for naught. Okay. But at the same time, on the other side of that is, if you can learn from it and have plans in place and detailed model work orders and everything, all of those things all kind of come into play when you do get in there to do the work. You're becoming more efficient, in that realm as well.
So we touched on this a little bit, but you know as our programs mature, um and we move from only doing PMs to exploring predictive and advanced, maybe even advanced analytics, or capital P, capital D, capital M, real predictive maintenance. How can we help our people through those levels of maturity, through those changes? What can we do to support our maintenance and reliability and our operations workforce as we introduce these new methods and technologies, and what can support them being successful?
Well, I always start with maybe at a bit of a high level is just educating people about reliability and what it can mean to them as individuals, what it can mean to the plant, but getting people to understand, that the actions they take, bring the results that they're getting. That can be negative or positive, but of course we always say training, training, training. I like to throw the education piece in there as well to
Hmm.
say, well, no, some people don't need trained, but they need educated on what a good maintenance strategy and what these things can do for them, because they're just not aware. They don't know what they don't know, right? And
Right.
it's very important on the operations side because they're often, helping to make decisions about the asset and and of course, their eye is on the ball of production,
Production, yeah,
right? But
output.
at the same time, if they can understand the effect, on them, okay, and their people, when the equipment's breaking down, and how better maintenance and reliability can change their world, the better off you'll be. So now you're creating what I like to call an operational pull towards doing these things, so that there's not people pushing back. Oh no, that's not going to do anything, or they don't have faith in the maintenance organization. I could go on and on, but the training piece is crucial. And what we're seeing today is that we've got a lot of folks, the baby boomers, are leaving to go into retirement, and they how do we capture their knowledge, okay, before they walk out the door, and how do we get our new folks, all right, to know how to do these things that let's just use a PM, for example. If we don't have standardized PMs, we don't have standardized procedures, the new person doesn't have a clue, right? They've not done
Right.
it before. Maybe they didn't get the opportunity to work with the person that had been there for years, that knew how to do these things. And so it's real important to capture the knowledge from those people. And there's just so many cool ways to do it now. We always used to talk about, well, let's get the seasoned veteran in the room, and along with some newer folks, and let's create those standardized, detailed PMs as an example. And that's a great way to do it. But now there's some technology, some AR technology
Sure.
that we can have that seasoned person go out there and with a pair of glasses on, or there's a lot of different technologies out there. Folks have probably heard of HoloLens and so on,
Hmm.
that can, in a sense, through video technology and being there on at the asset, recording the actual adjustments or repairs or whatever it might be. So it's bringing this whole new realm of the ability to capture the knowledge before it leaves us, and to
Right. And I think
standardize how we use it.
the newer workforce likes this technology, used to it. It's natural, right? Digital natives. And you mentioned the AR, the remote assist, electronic work instructions. Like there are lots of opportunities out there, like you said, to capture that knowledge, but also in a way that is, positively consumed by, I have great hope for all of these transitions into a more digital environment, a more technologically assisted, AI assisted way of work, because it is, like I said, natural. You know, my my daughter's 10 now. She hasn't ever known a world where we didn't have devices in our hands that could tell us answers to lots of different questions. So it's just an interesting time. And I want to thank you. I think we've answered all of the questions submitted and touched on a few frequently asked questions. But don't worry, listeners, this is just the first episode of the Ask the Expert. So I want to summarize a couple of the points that we talked about. We talked about the value or the different types of maintenance strategies and some pointers on how you can start considering when to adjust your strategy. For example, if you're doing too many PMs that aren't being effective, and when to start considering new strategies and different strategies to address those failures and those failure modes. We talked about some of the benefits of and some use cases of predictive maintenance. And then we talked about where predictive maintenance is going, Industry 4.0, the industrial Internet of Things, and modernizing maintenance strategies and taking a look at that, but the importance of the foundations, right? The importance of standard work, of discipline work management, and storing processes, and a little bit about reliability engineering. We talked about FMEAs a little bit. So I really appreciate your time, Randy. Thanks for joining us.
Happy to do it.
And for you listeners out there, like I said, this is the first of what we want to be a series. So we'd really like to get your questions on maintenance strategies, reliability engineering questions. If you've got some searing questions on capital delivery or design for reliability, send them in to us. We're going to find an expert to answer your questions, and then we'll feature them on the Get Smarter podcast. We will have some session notes and some resources for you in the session. Of course, for our expert, if you'd like to connect with Randy, you're on LinkedIn, right? Randy Heisler?
I sure am.
So find him on LinkedIn. You can connect with him there. And until next time, listeners, let's stay smarter, people.